Hello, I'm Michael Wybrow, and in this video I'm going to give you an introduction to iOS. So, iOS is the operating system that runs on Apple's mobile devices, and this is iPhones and the iPad and previously the iPod Touch. So, iOS was first introduced with the iPhone when that was the first iPhone was released in 2007, and it is based on OS X, which is now known as Mac OS, and it was a stripped down, modified version that was specifically designed for mobile devices, and that means that it had a small screen interface with touch controls, but it was still built on the Unix underpinnings of macOS. And it's worth noting that there is a derivative version called iPad OS that is now installed on iPad devices. It shares a lot of functionality with iOS. So really, iPad OS is sort of a superset of iOS, and it just has additional features, particularly for iPad interfaces, and we'll have a little look at some of those, but also for pointer input, so you can use a trackpad or a mouse with iPads. So I wanted to give some statistics on iOS. These are a bit hard to come by. I've pieced these together from announcement from earnings calls from Apple or from keynotes of their Worldwide Developer Conference. But just to give you some idea of the scope of iOS as a platform, there are almost 2 million active iOS applications available. This isn't the total that have ever been made available, because many of them um, you know, die after some point because they're no longer supported. But these are just the current applications that are in the store. Last year, Apple paid developers $86 billion from app sales. So that gives you some idea of the business side of things. They say, and this is slightly out of date from 2022, that Apple distributes 4 billion apps each day, and I presume this number is so high because people have multiple iOS devices and they re-download apps, so hence why this number is quite so large. And there are more than 2 billion active iOS devices worldwide right now. It's also worth noting iOS apps can run natively on Apple Silicon, that is M1 and M2 macOS systems. And this is because these new Apple Silicon processors, which have replaced Intel processors in macOS systems, are based on the ARM architecture, which is the same as the custom chips that Apple have been making for their iOS devices for a number of years. So I want to give a quick overview of the iOS architecture. It's a layered architecture. There's 4 layers, each with their own set of frameworks. Framework is really a library of code for a particular task. The important thing to understand here is Cocoa Touch, which we'll mostly be working with, is quite high level. These frameworks are written in Swift and they're object oriented. And as you get lower here, the frameworks get kind of closer to the underlying technologies and there's less abstraction. So Cocoa Touch is a lot of the key stuff we'll be using, things like multitasking, touch input, push notifications, and this includes UIKit, all of the standard UI components we use, GameKit, MapKit, which we will cover in week 7, and EventKit. As you start going down this stack, we start getting to sort of lower level stuff that's a bit closer to hardware. This is the media layer, has things like 3D graphics, music video processing, playback, also media streaming, which is playing music or audio to other AirPlay devices. And this is things like AV Foundation, Core Graphics, and Metal and AV Kit. So we'll cover a couple of these at various times. Then we get down to the sort of services layer, and this has things like data management, iCloud, which is a syncing service, application management, in-app purchases, and we'll look at core data and core location and core motion. We won't look at CloudKit in the unit because it requires a paid Apple developer account. And then at the lowest level is the core OS, and a lot of these parts are C-based, and they're things like security frameworks, sockets, threads, other bits and pieces. So we won't really be delving into any of that. The environment we use for creating iOS apps is Xcode. This is an integrated development environment produced by Apple. It's available for free, but it only runs on macOS platforms. It includes a code editor, a debugger, an interface builder. It includes simulators for all of their devices, so iOS, iPadOS, watchOS, tvOS, the CarPlay stuff for iOS. It has built-in help, and it includes all of the developer tools, so all of the Swift toolchain is bundled as part of Xcode. So it's really almost everything you need is just Xcode. So if you have a Mac of your own, you can download it. It's already pre-installed on all of the Monash lab computers. So it is worth mentioning that Apple do have an iPad app called Swift Playgrounds, which can be used to develop and release iOS apps now, but these must be written in SwiftUI, and they're a bit limited in their functionality. So I guess this is the first step towards having a full version of Xcode that runs on an iPad, but we're not there yet. So Swift itself is a language written for macOS and iOS. So the iPhone has been around since 2007. We weren't able to develop our own apps in the first couple of years of the iPhone. After a couple of years, Apple made available some toolkits to be doing that, and at that point, people were writing iOS apps in a language called Objective-C, and Swift was the replacement to this that Apple came up with in 2014, and we used to teach Objective-C, and we switched the unit a couple of years after Swift was first released. So Swift is up to version 5.7 now. I mean, basically the language is supposed to be faster, safer, and more concise. As a teaching language or as a language to use, it's much nicer than Objective-C. The syntax of Swift is quite similar to C or C++. There's a few differences, and we'll go into that in the later videos. Okay, thanks for watching.